Statistics is inferential statistics. It's called inferential statistics. The inferential statistics, this is another part of statistics apart from the descriptive statistics. This is in fact also called the inductive. It's inductive statistics because now you induce from the sample to the whole population. Here, the inferential statistics is, as I can explain, is the generalization of the sample findings to the whole population through performing the estimation methods, test of hypothesis, and then take a decision. Yeah, this is the definition of inferential statistics. In fact, here it's also called inductive statistics. You generalize the sample findings. That means you have the sample. This is the sample data. This is sample. And from this sample, you get the findings. From this sample, you have the findings. These findings. And this sample must be drawn from the population. The sample must be drawn from the population. That's why maybe you take a sample like this, and see this one that you bring it here. So, and then you do analysis from this sample data, and then you generalize to the whole population. When you generalize to the whole population here, you have to perform some methods of estimation, methods, and test of hypothesis. This also, another chapter will have to cover it, but you need to have a sample, and a sample must be drawn from the population, and having the data from the sample, you do analysis as usual, and then you generalize these sample findings to the whole population. In fact, here, you are looking, you get some statistics, and also you need to get what? You need to get parameter. You need to get parameters. So that is why, for what we call statistics here, statistic is a measurement made from the sample. From the sample. Any value that's measured from the sample is called statistic. While a parameter, any value computed from the population is called a parameter. So, meaning that when you are performing inferential statistics, you are looking at a statistics that correspond to a parameter of that population. So, this is the other part of statistics, which will be covered later, but now we are going to concentrate on descriptive statistics. Generally, as you can see as the summary, you have the statistics. I've seen it, and you have seen that this statistics has two branches. You have description, and also you have also inference. These two branches of statistics, and these two branches of statistics, when you are doing the inference or description here, you want to bring something visual display here. display, such as pie chart, histogram, and whatever. And also, you can also bring the numerical summaries. But in inferential statistics, which is a generalization of the sample findings, you need to bring, here you have to estimate parameters. And then also you need to perform the test of hypothesis. And of course, the aim of overall, either in the solution here, you need to make a decision. And also here, you need to make a decision. So that's why you need to make data collection carefully, making analysis carefully, so that a decision that will come out will be also very, very important. Now part 2, we are going to see so let's go to some vocabularies. That was an introduction. But now we can have now some vocabularies. Yeah, we can have statistics and vocabularies. Yeah, and vocabularies. Here, of course, you are familiar with some terms. Example, when we talk sample. A sample. A sample means that a small representation. It's a small representation. Or it's a small proportion of the whole. Or mathematically they call it a subset. Or a subset of the population. A subset here, when we talk about a subset, you understand when, for example, you have this population here. This is the population. And among this population here, you have this, suppose these are the number of students at INES Ruhengeri, for example. And then you want to draw a sample from this population. Suppose you may have something like this. So this is a sample. This is a sample. You see now, not a sample must be drawn from the population. That's, you have to know that. A sample must be drawn from its population. So a sample must be taken from its population. Don't take a sample and then attribute to a population which is a different. So a sample must be drawn from that. So then, apart from the sample, you need also to have a population, what we call a population in statistics. A population in statistics is what? A population in statistics is different from a population in demography. In statistics, a population, this is the this is entire collection of population. This entire collection population or observations, objects, and so on. So the entire collection, you may have maybe number of students in a country. So students, in Rwanda, there's a population. You may have number of workers in the world. This is a population. And from this student in Rwanda, you may have INES student as a sample. You may have a UR student, etc. So this population here covers all observations. It covers a lot. In fact, this is universe. It's a universal set. It's a universal set where everything belongs. When we talk about sets, you understand very well. In a set, you may have a set A, 1, 2, 3, 4, 5, 6, 9. And you may have a set B, 2, 4, and so on. So as long as you see the 2 also belongs to set A, element 4 also belongs here. This to say that B is a subset of A. So mathematically is B, which is a subset of A. So on statistics, you can say now B is a sample of A. Hope this you understand. Good.